There she is. Okay. Loves that voice. It's boring like all those voices. My wife and I were in Greece 10 years ago, and we rented a car and they had built-in GPS, and the voice sounded like a Russian. And we used to make fun of it all the time. We were incessantly making fun of the GPS voice. All right. So we're going to show a film. Damn it. Yeah, we're going to show a film on a duct blaster tonight. So the first question on the test is, what is a duct blaster test? Now, you could look at the word duct blaster and probably figure out what it tests, right? And no, it doesn't test blasters. So this may be a thing of the past, but we still have ducted air conditioning systems, you know. In 10, 20 years, they'll all be gone. But we have them now, and the ducts leak, and that's a tremendous loss of energy. So we have, just like we have a whole house blower door, we have a little duct blaster. It's like a specialized blower door that just tests ductwork. So what does a duct blaster test?
Are you asking us?
Yes.
Oh, it's a specialized blower door test that tests the ducts.
And it tests what does it test the ducts for?
Leaks, how well they're sealed.
Leaks. Yes, we're all about leaks. Blower door tests house leaks. Duct blaster tests duct leaks. All right, you got the first one right. Okay, remember I talked to you about backer rod, and I was going to show you examples of it, and I brought them home, and I was all ready, and then my garage got too crowded because I'm having cabinets stored there, so I took them all back to school. So I'm not going to show you the backer rod, but that's a little. It comes in a cellophane bag, and they're anywhere from 1/4 to 3/4 of an inch, and they're little foam strings, and you just stuff them in wherever you need them. So if you have a big hole that you have to caulk and it's deep, don't just ram in 2 or 3 bottles of caulk, because A, caulk's expensive. B, it'll go in, but with that wide of stuff, when it dries, it separates, and you'll get big holes, big cell holes in it, and it'll be useless. So you put the backer rod in to bring it up to like 1/4 of an inch of the surface, and then you got a little 1/4 inch deep thing you can caulk easily. So if you have mold and drywall in a dry rot in a wall, what does that indicate?
Moisture buildup.
Moisture coming from somewhere. You got it.
What was that question one more time, Patrick?
Mold. If you discover mold and dry rot in a wall, what does that indicate? This is a true and false question, but it indicates water somehow got in there. Can't have mold and dry rot without water. Remember when the first class we did an audit survey? We did a sustainability or an energy audit. Remember that? I mean, it was all of like 7 weeks ago. You guys have memories that go back that far?
Yes.
Well, I only go back 3 weeks, but I have all the goods in my hand, you know, so I can fake it. So what's the advantage of sending a survey to the homeowner before you make an on-site inspection?
Gives you an idea of what to look for.
Yes, exactly. Saves time, gives you an idea what to look for. That kind of pre-inspection survey might ask about utility bills. You know, if you have high utility bills and you know there's leaks and stuff, so that's a good indication. You might ask them to locate, to designate drafty rooms. Everybody knows a bedroom that's drafty or a hallway, you know. And faucet or toilet leaks, thermostat settings, those kind of things. Like, how do you set your thermostat? Oh, we leave it at 80 degrees 24/7. And then they wonder why their utility bills are high. So those are kinds of things that can go on a survey. And then you don't have to, you know, you can ask them that when you get there, but then it takes 5 minutes to ask them that. Time is money. So we talked about heat transfer, and there's really only one type of heat transfer. Remember what it was? The main one? It wasn't convection.
Conduction.
Conduction, yeah. So convection is when air moves and then heat transfers, but it's not actually a transfer of heat, it's a transfer of the area. I mean, that's a fine point, but still. And radiation is the other one they talk about. Radiation is not really heat yet. Heat comes from molecules and atoms moving faster. And radiation makes them do that, but radiation itself is not hot. Okay. What damages color in fabric in a window that's got sunlight on it? Anybody?
UV radiation?
Yeah, same with your car, what do you call it? Your car upholstery and what do you call the lining, the dashboard lining? Dashboard lining? You know how that can get beat up by the sun too.
What was the question again, Patrick?
Well, I'm not
Sorry.
giving you an exact question, but if you answer the question, you'll have the information you need for the test question. So
All right,
it's
I'll go back.
yeah, it's about what types of light coming through windows damage damage. So you said ultraviolet, and how about heating up overheating places? That's got a name, that light. Anybody? Heats up fries sometimes, French fries.
Oh, I don't know.
Talking
Yeah,
about,
you
like,
go to
baking?
In-N-Out Burger and they have this light on the fries, keeps them hot. What's that light called?
A heat lamp?
Starts with it. Well, yeah, it comes from a heat lamp. Starts with an I.
Infrared?
Yeah. So the you know, we've just given names to the electromagnetic spectrum. You know, they're all different they're mathematically different wavelengths. It's a continuum. And we pick out a certain wavelength like ultraviolet, and it's just a certain wavelength, but we know it does damage. So we say, okay, we give it a name. That's ultraviolet, that does damage. It's just a number, really. It's just a vibration, a degree of vibration. And then a little down more is the visible light, and that does nothing, but that allows us to see. We can't see ultraviolet or infrared. We see visible light. So our eyes are just made for that little bit of the spectrum, and we call it visible light. And then further down is infrared. It's a type of photon that heats up things, particularly on our scale, human scale. So we give that a name, infrared. Okay, we talked about why convection happens, why heat rises. One or two of you knew the answer. Anybody want to repeat it? It's kind of counterintuitive because we don't think of gravity as affecting anything but solids, you know, like your body or baseball or whatever, or cannonball or whatever. But gravity affects anything that has mass. So gases have mass. So when they're dense, the gravity pulls them down. When they get heated, they get less dense because they separate. So per cubic foot, you're going to have less mass when it's heated up. So they break the reins of gravity and they start going up instead of down. Yeah. So convection happens, it goes up when it gets heated. Now, these are things I want you to remember. Water moves from, and these are questions on the test, so I'm just going to give them to you. Water moves from wet to dry. Okay, so when you spill a beer on a table and you take a paper towel, the water sucks into the paper towel, right? So it's going from wet to dry. I mean, you experience that all the time with water and dry things. That's a law of thermodynamics. And then another one is things always go from cold to hot. No, from hot to cold, sorry. Now, these are going to be true and false, so make sure you get it the right way, like I didn't just now. So things move from hot to cold. So all the warmth in the universe is going toward cold. They figure someday it'll all get too cold to have anything worthwhile, but that's a long way off. And then what's the third one? Pressure.
Patrick, doesn't that kind of go against the global warming thing?
No, it's different scales.
Yeah, they're different scales. Not really, but I mean, you could think that way, but it's not. If you go into it in a little detail, it's not really that way. And the pressure, the third one is pressure. It goes from high pressure to or low pressure. It goes to balanced pressure. So for instance, if a house has a different pressure than the outside, it will tend to balance. So if the outside pressure is high and the inside pressure is low, the house will suck in air from the outside to try to equalize that pressure. And vice versa, if the house is pressurized, then more than the outside, then the air will try to leave the house to balance it out. So if a house has negative pressure, that means it's missing pressure, right? So it's gonna try to get pressure from the outside. So how does it do that? The pressure is air pressure. It's gonna suck air in, right? So if the house has a low pressure, it's gonna tend to suck air in. So how does a house become negatively pressured?
If it's hotter than the temperature outside.
Yeah, but it happens because of that. But what actually happens when the air in the house is warm or heated up?
Not enough circulation or vents for
Yeah, convection, right? Because if it's heated up, it'll rise. And then when it rises, then there's no air underneath it. And so that's a void. So it'll suck air into that void. And it'll suck air from anywhere that's open. If there's no place like a chimney or something that's obviously open, it'll just come through whatever cracks you have in the wall. So that stack effect is when the air rises. What about exhaust fans? You have your bathroom fan and your kitchen range hood fan. Those exhaust the air out, right? You're trying to get rid of that smelly bathroom air and oniony. Depends on what ethnic group you're from, what your kitchen smells like. If you're Korean, you're trying to get rid of all the garlicky air. No, you love the garlicky air. Yeah. If you're Italian, you want to get rid of all the oniony air. No, you love that onion air. Well, whatever. So, so exhaust fans depressurize a house because they're sucking air out and they're not replacing it. So the air's got to come from somewhere. So, and then wind effect. If the wind blows on one side of your house, it blows air into the house and the house becomes pressurized and it leaves the other side. So wind just goes right through. I have a question that says, what is the old building code requirement for air changes per hour? It's old in the sense that that was the only number they dealt with. Now they have other ways of approaching it, but it's still a valid measurement of air change. Do you remember what that was, what number that was?
0.33, something like that.
Yeah, 0.3 or 3.3 per hour, or 1 every 3 hours. Yeah, it's the same thing, however you want to put it. Okay, difference between ventilation and leakage.
Intent.
Intent or control, yes. Ventilation, you're intending or you're controlling the air in a certain way. Leakage is just coming where it comes. And it may not be what you want or intend. Good.
Hey, Patrick, is this next week?
I'm sorry, what?
Is this test next week?
Yes,
Okay, on Tuesday
yes.
or
On
Monday
on your Canvas test area.
during the same time, and it's just for the time of
Yeah,
class.
I'll probably open it up at 5. And then you can go till, and now I'll go till 10. 5 hours, that should be enough, right?
Okay, how many questions?
50. But
Okay.
you're getting all the answers tonight, so it's a short 50.
On Tuesday, you said, or on Monday?
Monday, I'm sorry. Lewis is trying to foul me up.
Yeah, I'm
Yeah,
gonna trip him up.
Same time next week. But I will open at 5 and go till 10 for anybody who needs extra time. If you don't, you could do it from 5 to 6 and then you actually have an evening to yourself. Wouldn't that be fun? Okay. Why can sublegal air changes per hour cause health problems?
Poor air quality.
Yeah, it'll be poor. Okay, that's one step in the direction of an answer. What makes the air quality poor?
Carbon monoxide or dioxide?
Carbon monoxide is a good one. You're not supposed to have that, but if you do, you want your air changes to be legally. What else besides CO? We haven't talked a lot about indoor air quality. We do a lot more about it in the next semester's green building. We have a whole unit on indoor air quality. We have talked about it in this class. But this class is about the mechanics, about getting rid of stuff or bringing in stuff. It's not about particular stuff. How about moisture? So does anybody know what kind of health problems over moisture causes? I think it pickles your brain. No, that's not a real.
Respiratory.
Will
What?
moisture create mold?
Well, okay, indirectly, yes. Moisture will create mold and rot, and that's not good for you. But also moisture itself, if it's too high, is not good for you either. Your body doesn't like moisture above a certain relative percentage. So yeah, all those problems. So also, we haven't talked about toxic furniture or toxic things, but say you're a painter and the only place you have to store your paints and your solvents is in your garage, and your garage house interface is not real tight. You can get some of those solvents in the air. You don't want to breathe that stuff either. Also, furniture can have, what do you call it?
Off gases.
Yeah, it can off gas. What's it? Formaldehyde is the big baddie in furniture. They've made
When do they-
efforts. They've made
When do they
efforts.
stop?
What's that?
When do they stop off gassing?
Well, I don't know. You can find out. They vary by how they're put on and what particular material it is, but they don't last forever. And they go beyond when you can smell them too. Like, new carpets you can smell for a while, or if they're really cheap carpets and have a lot of formaldehyde, you can smell them for months. That's all bad, and even after you stop smelling them, it can be bad. So you just have to look up the material that's in them and look up what the life span is of that stuff.
Are they still making stuff with formaldehyde?
Yeah.
Yeah.
There's two major kinds. And they've gone to the one that's less bad, the phenol formaldehyde rather than the urea. But it's not as bad for sure, but it's still not great. But the only reason they use it, it's a binder, it binds the glue. The only reason they use it is that's very cheap. So it's just a money thing, you know? And they start making products and the health conscious builders and the environmental builders will buy it, but not all builders will buy it. So they usually go out of business because they can't compete because of the money. So it's kind of too bad. So why do we figure the appropriate ACH by theoretical methods before we run a blower door test?
As a benchmark?
Yes, we're comparing, if we just ran a test, we wouldn't know what the results meant. We're comparing it to tight houses, loose houses, what the government requires for ACH. So there's all these standards we're comparing it to. So we have to do the theoretical standards. We know what the government minimum MVR, minimum ventilation requirement. We talked about that last week. We know that one. If we're trying to have a tight house, then we want a table with data on what kind of blower door results indicate the house is tight, and so that kind of thing. So yeah, we're doing it and we're comparing it to a standard. A blower door sucks all the air out of the house, and it's assuming that it's the test that's creating negative pressure. And why is it sucking all the air out of the house?
Negative pressure.
Yeah, but it's creating negative pressure, but that's not why it's doing it. So what are you measuring with a blower door test? The main test.
The amount of air that's being pulled.
That's being what?
That's being pulled like through the cracks and whatnot.
Yeah. You're measuring the leakiness, how much air loss. So the way we measure how much air is lost is by how much we establish a pressure, because you got to have a standard for in and out. So we establish 50 pascals because that works pretty well. And then we see how much air it takes to keep the house at 50 pascals. So that blower door blows out the air and the air comes in, and then that'll give us an indication. We can track that. So we measure the speed of replacement air. That's the simplest way of saying it. Now, you saw me take apart a blower door test. We didn't get a very successful result. Not that important. Actually, it's more important to show you guys that it's not that complicated a piece of machinery in terms of putting it all together and sticking it in the door. But do you remember what the main parts of the blower door system were?
The fan and the
Fan is
computer.
one. What else?
The computer module.
Yeah, exactly. Manometer it's called, but you can call it a compuper. What else?
The door frame.
Yeah, the frame, the door frame. Yeah, those are basically. I mean, you can list it anyway, but those are basically the three things. Now I'm not going to give you this one. I'm going to say homes leak through the following, and you just have to look at the notes, the handouts we did about leaks. Off the top of your head, what do you think they are?
There's only one.
Doors and windows.
Doors and windows is one or two. What else?
Holes in the wall.
What's that?
Fireplace.
Are you ready?
Fireplace, yes.
Holes in the
Yeah.
wall?
Holes in the wall, yeah. They call them plumbing penetrations or whatever, but it's the plumbers that usually, electricians usually go, between the studs. They don't usually go outside. So they're less guilty, but plumbers really, they're going in and outside of the wall all the time. They make holes. Okay, let's talk about air barrier. Why does an air barrier help save energy? What's an air barrier? What does an air barrier do? That's the first thing to remember.
It holds air inside
Yes. So why do we want to hold air inside?
to prevent hot air from releasing outdoors.
And why do we want to do that?
To prevent leaks and the house getting colder.
Yeah, one answer is comfort, and the other answer is money. Actually, there's a third answer, but the big ones are money. You pay for that heated or cooled heat, and to let it leak out is like stupid. But also, the more energy you use, the more global warming you're creating until all of our juice is sustainable. We're approaching, we're getting there, but we're not there. So those three reasons. Do we need plastic sheeting under the sheetrock on the inside of walls in Santa Barbara, given our weather here? No, that's kind of overkill. The big thing that an air barrier does is stop hot air from getting into the core of the wall and having cold air from the outside hit it in the middle of the wall and causing the heat, which holds a lot of water, causing that water to condense and wreck your fiberglass insulation and wreck your sill plate, maybe rot your sill. But when it's not cold enough to bring a dew point into the wall, and it certainly isn't that cold in Santa Barbara, we have less to worry about that. So we don't really need that. And it's costly to put that barrier up. So we don't really need to use that one. We do want to keep hot air from going out too fast in the leak. So we can plug the leaks, and we could do a drywall barrier. Drywall is a pretty good barrier, but sometimes it's held up from the floor. Anybody know why drywallers hold a drywall up from the floor half an inch?
Is it so you can get your flooring underneath it?
That may be a reason, but usually there's a baseboard, so there's not too worried about that, but maybe. But also, yeah, the floor may not be straight, right? So if you start a run right against the floor and the floor waves a little, the next board may not fit real square with it. If you give a little room, then you'll be sure to, tweak that. I don't know, I'm not a sheetrocker, but that's what I always thought. Those two reasons are pretty good reasons. But because they do
Movement
that.
of the house.
What?
Movement of the house. Since the drywall's not touching
No,
the
the
ground.
drywall,
doesn't
like
crack.
if the floor, say there's a crown in the floor, a big crown because they used old wood. I mean, God knows what, or it just wasn't framed properly, and the floor is not a straight line from one wall to another. Well, if you put your sheetrock right on the floor, it's going to follow it, like going up a hill and down, and then the ends of the sheetrock aren't going to be together, So you want the sheetrock to be tight fitted from sheet to sheet. So it's kind of like the reason you snap a line at the end of a rafter thing. The rafters might have different lengths if you cut them all ahead of time. So you cut up a little bit above it, and that allows for variation. What were we talking about? Oh yeah. So because the sheetrock's up, sometimes air can get in underneath that half-inch space and get behind the sheetrock and go up into the stud bay. So if you want to use the sheetrock as an air barrier, you have to take caulking and put it along the bottom plate above that space so the air can't get up in there. And then there's certain other places. Oh, El Capitan just burnt down. Oh, shit. It said, Dylan,
What's on fire?
evacuation order for the Elisa fire expanded to area between El Capitan Beach State Park and West Camino Cielo Road. Crap. Evacuate immediately. I'm not sure, you know, I'm never sure how these explanation goes.
I'm texting them.
Area between El Capitan Beach State Park and West Camino, that's right up to El Capitan, right? And shit,
Yes.
I'm only a few miles south of that.
It's 7
This is not
miles.
looking good.
I don't think it'll get to you, Patrick.
Let's hope not.
I think the
I'm in
wind,
no mood to evacuate.
the
That's
wind.
what we said about the Thomas fire.
I know. They all come close to me for some God knows why reason. They come over the hills near me,
Because you're hot stuff.
I guess. Or cold stuff, because hot goes to cold. right?
Animals.
That wind just kills everything. I mean, really hard to deal with.
Probably somebody smoking a cigarette that started it too.
I love these reverse emergency alerts, huh? Because you
I
go on
didn't
the, have you ever tried to find what fire activity is going on by going to the, you know, Santa Barbara fire activity today, and then put the date? And they don't, now why is this? You guys tell me this. Why do they leave all the fire reports for the last 5 years on the internet, on the, you know, the browser? What possible reason would, because it just confuses everybody, and they don't even put the dates until you get into it and you go, oh God, that was 2018, you know, forget it.
public record or something. This one you can watch live on Twitter. I noticed
Hey.
earlier when I
This public director thing's a great answer, and you know what? You could have 2 freaking channels, one for archived stuff and one for current stuff. How about that?
that's a good idea.
I tell you. All right. How can insulation be retrofitted into a wall that does not have insulation? Everybody know that? Why must fiberglass bats touch all 6 sides of a stud cavity? I'm asking the class.
Because of air.
Yeah, you don't want to allow any space for air to move in there, right? We call it sometimes they call it a convection loop, but that's not totally accurate because the loop is literally a loop. Is where hot air rises and then it cools and goes back down. So just in a room, you'll have convection loops. It's I call it a convection pathway to go to the top plate. So you don't want to allow any of that.
The previous one was it being sprayed in or blown in.
Yeah, cut a hole in the walls and blow in the whatever we're doing. And then remember the way to put fiberglass on the wall? Now, if it's got to touch 6 sides, right? What happens when you have a plumbing pipe down the middle of that wall, halfway between the front and back? How can you have fiberglass touch all 6 sides when you have that?
Don't you cut it like you relieve it?
Yeah, you split it. That's the great thing about fiberglass is it's comes in kind of layers and you can just pull it apart so that the front touches the front and the back touches the back and it just goes around the, yeah. When it's, you know, loose fill, it automatically fills front and back, but you got to watch it when you're doing fiberglass bats. Okay, it's important to keep ventilation and wind washing. Oh, and wind from washing across rolled attic fiberglass insulation. So in a house with a cathedral ceiling or an attic, where it's vented through the eave, through the rafters, the wind can get up in there and it can blow laterally across the insulation. The insulation's made for air coming up through the house. So it's going horizontally. And if you have air coming in the rafters, it's roughly horizontally too. So it blows in that insulation. That's called washing. That's no good. It doesn't stop it if it does that. The insulation in your house, the heat in your house is going up, and then it's taking its time to get through it. So that wind washing, we need to stop it, and they have special baffles. So another question is, what do eave baffles? So this is where you need to know the word eave. Eaves around the rafter tails, okay? The bottom of the rafters. So there's baffles that go all the way up the rafters, like in a cathedral ceiling, and keep the fiberglass from eliminating that airspace. But then there's also special eave baffles that are down at the bottom where the wall hits the rafters. And those keep the ventilation and the air from washing the ceiling or the ceiling insulation.
Hey, Patrick, quick
Yes.
question.
Yes.
Back to the fiberglass insulation and that aero barrier stuff that they were, spraying in the air and it was sucking out.
Yeah.
And with something like that, you would still have to insulate the walls if they're not insulated, right? You couldn't just like aero
Yes.
barrier them. It's just for
Now one of the air barriers was about a house in New Jersey or Philadelphia or somewhere, and it had brick walls, so there was no inside to the wall to put insulation in. And so they said nevertheless, if you keep all air from going out of the wall by sealing all the holes, it'll tend to help that heat stay in the house, even though the brick's not a great insulator. So it's not perfect, but it's really costly to redo a brick wall because you have to either put rigid. You don't want to put on the outside because the brick's the whole, it's got that look. That's why people buy those houses.
What's the easiest way, like what do most people do around here? Because like I've re-insulated, ceilings and some walls in my house by actually like removing the drywall or getting up into the attic and putting down the fiberglass rolls. But what do most people do? They just cut holes in the drywall and then just blow it in?
Yeah. And you can, rent the stuff from Lowe's or Home Depot and, do it yourself.
Does that stuff work as well as the rolled out like sheets?
Well, that insulation handout I gave you, there's a bunch of pages. They compare the insulation and the loose fill, fiberglass, loose fill paper, what's that called? What's the loose? What's the loose? Huh?
The loose. It seems like there'd be more gaps in the loose fill stuff than like the sheets,
Well, the sheets, you mean like rigid foam?
Like the rolls that you buy at Home Depot or somewhere where it's got a backer on it, like a paper backer.
Yeah, like the fiberglass.
Yeah, it seems like that would work way better than just the loose fill stuff.
No, they work about the same. Yeah. Especially if you put the loose fill in at a certain pressure, and pack it in a little more.
How are you able to do that? Like through just one small hole in the drywall? How do you?
Remember they said drill a hole halfway and then drill one toward the top.
And then you just pack it down with like a stick or something.
Then you just you're talking about spraying it in, right?
Yeah.
And then you just put the hose in it. Yeah.
Okay.
Yeah, that works pretty good. They've done that. Because, it's better than taking the wall surface off. It's, you've got cabinets and furniture. It's a real mess. You can do that if you're really into it, but the cheap and dirty way is to drill holes. Oh, if they didn't insulate the floor joist above a crawl space, which new homes all have it done, but you might have an old home. And you have a crawl space and you have those floor joists and there's nothing in between. What can you put up in there? So you're obviously not going to spray anything because there's no bottom to it. It'll just fall out to your face. You could put little thin plywood everywhere and drill holes in that and fill it, but that's kind of the long way. So most people just put fiberglass. You know, the floor joists are usually on a 16 center and just go buy 16-inch fiberglass. They're usually 2x8s or bigger, so you can get the appropriate thickness of insulation and put it in there. You have to crawl under the crawl space on your back and staple it. You know, it's got the, get the back stuff and staple it to the bottom of the joist. But that's probably the simplest way to do it. If you really want to make your house airtight, you're going for a passive house or you're living in cold climates, get under there and shoot isonine, closed seal spray foam, and that'll make an air barrier. And then none of the wind from that blows through your crawl space will come up into the house. And it does. If you get any kind of air movement, it'll make its way up. So some people have a seal above the floor. They may have a plastic layer, but in the old days they didn't. They would just put plywood down and then put the floor. And so they're kind of small areas of leakage that can go through. But if you spray from the bottom, then that seals everything tight.
What about like a rigid board?
Well, you know, you can put rigid in, but it's going to leak around. It won't be an air barrier because it's going to leak because you can't cut it exactly right. But some people put it in, and that's easy. You can nail through that at an angle into the joist, and that'll keep it up. And then you can spray foam along the edge. You don't need to have a big isonine sprayer. You can just buy spray closed cell foam along the, you know, where the insulation touches the joist, and that'll air seal it. So that's a cheaper way. Yeah, you can do that too.
Would going into a crawl space and spraying isonine be extremely unhealthy?
Yes. The answer is yes. So what you would do is if it had a couple of entryways, you'd get an air circulation going, and then you'd have to hazmat yourself, you know, just really wear the works and have a mask, you know, the painter's mask with the cartridges, not just the dust mask. Yeah, it's nasty shit. Okay. And bat insulation, where would you recommend that? Where would you put that? In a bat cave. Ha 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 ha. No? You know, Batman has a lot of bat insulation in his place. That's what I hear anyway.
Oh man, you're full of it tonight.
I'm tired as shit, so everything that comes out of my mouth is crazy. Okay. So, is some alien trying to get a hold of me? Hey,
John,
That's racist.
Okay. Bad insulation. Did I hear that answer? Otherwise, you're on your own. Where do you put fiberglass bats normally?
Attic?
You can, but that's not, that's about 50-50. A lot of people put loose fill because you can go up there and do it. But yeah, I'd say it's probably, I mean, who knows, but I've seen both. You see both. But in walls, fiberglass is still the most popular wall insulation.
I was doing a remodel, not a remodel, but rot repair, where we had to take off some siding.
Yeah.
And expose the insulation that was in there.
Yeah.
And when I was gonna put it back in, I was gonna put it in like with the stapling on the studs and stuff.
Yeah.
But then my boss said to flip it around because the paper is supposed to be on the interior. Does that matter? Does that make a difference?
Well, some people call the paper backing an air barrier. But when you've got a lot of staple holes, when you're stapling in the studs, it's not a great air barrier. So that's what he's probably thinking of. I would have done it the other way, like you were gonna do it.
Yeah, where it's just cleaner and easier because you can just staple it to the,
Yeah, because either way, you're not having an adequate air barrier. So cancel that out. But if you do it the way you wanted to, at least you're getting the insulation to fill the void and be more effective.
Yeah, because it was kind of like sagging a little bit.
Yeah.
Jack, put in the paper?
What's that?
Oh, I was just asking, which way were you putting the paper?
Oh, they had opened it up from the outside, and the paper tabs are usually on the inside, but you couldn't get to the inside because that's sheetrock there. So I would just do it from the outside, because at least then you're gonna, it will sag possibly. Sometimes framers are really bad, and they, in the old days too, and they may make a 16 on center that's a quarter of an inch bigger than that by accident.
Oh yeah.
And then your friction fit's useless, right? It's going to sag in that bay. So at least if you have a staple, you can staple and keep it up in where it's supposed to go, even though it'll still have a little bit of leak on the side.
So Patrick, if you're doing that same thing, but you're up in an attic and you're putting it on the ceiling drywall from above, are you putting it with the paper down on the top of the drywall, or are you flipping it so that the paper is up at the studs?
No, I would put it up on the upper part. Usually they don't put faced fiberglass in attic bays.
They blow
because it's not going to fall. The gravity will pull it, to the bottom, and it's not going to sag in any way. So you don't have to worry about too much about it moving. The coolest thing they do is put if you want to do an air barrier, if there was no air barrier, I would still spray the edge where the drywall and the joist are. I would spray that with some kind of foam and create an air barrier. And then I would put fiberglass, unbacked fiberglass in it. And then I would put fiberglass going across the joist, like you saw in one of the movies, one of the YouTubes. And that'll cancel the, what's the word I want? Thermal bridging through the wooden joists. You're putting something over those joists. But you may not need that much insulation. So, that varies when you can do that. But a lot of people do that because the joists aren't that big. They used to frame with smaller joists. You have maybe 2x6. You're not going to get a lot of insulation in that. So you can afford to put another layer going across. The attic bears a little bit of focus because the hot air rises. And so your ceiling's a very vulnerable place. So you want to try to do a good job, without going overboard. But I still think one of you guys ought to open a company that makes attic hatch hardware. But that's the last I'm going to mention it. People make billions out of just gizmos, That's the way this place is. Okay. Where would you use rigid foam board insulation?
For like a multiple story house or something, like the
Where in a multiple story house?
like on the ceiling, so that you can't hear the upstairs neighbors or something like that.
Well, yeah, that's an idea. But I don't know how rigid insulation compares with just plain fiberglass, or that rock wool we saw last week. In terms of sound dampening. So
recently found some sound caulking. Have you ever used sound caulking before?
No,
It's caulking made specifically for like, acoustics.
yeah, no, I've never seen that.
Yeah, I haven't either. Someone just brought over a case and was like, "You guys want it?" And
Yeah.
yeah.
Well, yeah, so, I wouldn't use see, the thing, I mean, if you're gonna put soundproofing, well, if you're gonna do a ceiling and you put the insulation against the lower end of the joist and then put drywall, under it, and then make a finished ceiling, that's an idea, but that's a lot of work. If I was doing, that's good soundproofing because you're just like thermal bridging, you're sound bridging. You're not letting any wood come through. So that would be good. Most people don't do that. They just fill the inside. And that's only partially good because you still have joists that act as little drums, that the vibration goes through the wood. So, yeah. But anyway, you might use rigid there, but there's a more common place. Now, you're not going to use it in a wall, right? Why not?
You can't cut for the bays.
Yeah, you have to cut each piece, and that's going to be a pain in the ass. And no matter how hard you try, you can't cut those things perfectly. And when you buy the bats, they're just cut right, ready to put in, right? They fit really snug if the layout's good, and you can just staple them. So it saves a lot of work, procedure. But on the outside is the really ideal place, and it's kind of similar to what you're saying for the ceiling, because that thermal bridging, you go over all the studs, and you don't get heat loss through the studs because it hits the rigids covering everything. So that's the biggest use of it nowadays. There's always, soundproofing. There's always incidental uses for it. It's great stuff because you can cut it easy and do it. But probably the biggest use would be on the outside.
We did rigid foam in a small wine cellar.
Where?
What's that?
On the outside or the inside?
Inside.
Oh, to keep the cellar from getting warm from the rest of the house.
Yeah.
Okay. And did you put on the outside of the studs, like in the rooms around it?
Actually, we did spray foam on we did half spray foam, half
wow.
rigid.
Wow.
Yeah.
That's pretty fancy. Yeah, so I learned something from one of the films we saw the other day. And that is, if you're going to use Icynene and closed cell spray foam is expensive. It's the most expensive insulation. So people try to use it as little as they can. So they were just doing the outside of the stud bay, maybe a couple inches in a 3.5 or even a 5.5. And then they were putting fiberglass on top of that for the rest. Now, if they didn't do the plate on top, the plate on top would be colder than what's in the wall. And the warm air would come into the wall and go either before the fiberglass or after it got through the fiberglass straight up to that plate and wouldn't even go through the Icynene. So I've noticed that they're spraying the top, the plate itself, they're spraying with Icynene like an inch or two, so that keeps the convected air from going up. It won't be invited to go to cold. It won't know there's cold air because the Icynene's shielding it. So that's how they get away with it. But when they first started doing it, they didn't do that. And I would say, how can you guys do that? There's going to be a pathway, a convection pathway. But I've noticed in the movies lately that the top part's sprayed. And they put a minimum amount that, like, it's got to be 2 inches of spray. So it's not negligible, So that's good. Where would we use Icynene? A closed cell foam.
In the remodels.
Well, where and why?
Because you don't have to open the walls up. You can just punch a hole in, right?
I don't think you can use Icynene that way. Remember this old house when they looked at the different things, and the guy asked him, "Can you punch holes and spray?" And he said, "No, it has to be an open wall cavity to use the Icynene." That's where I heard of it.
Was it
So yeah,
Icynene for
because you can't tell where it goes, and it might swell too much. Yeah, it's got to be open. When it's open and it comes back over the level, the plane of the studs, you can always take a scraper. In fact, that's the best way, I think. You can take a scraper and just make it right even with the studs, and then there's no air gap or anything.
Doesn't that make it more porous though? It doesn't have like that glazed skin.
Oh, no, that's a point. I've never heard of that, but you're right. It would, but I don't think, well, you're just doing the surface when you're scraping it. So I don't know how, if it doesn't penetrate far into it, that it matters. That's a good question. I'll see if someone knows that. But the big use is as an air barrier or air vapor barrier. If you want to have a really good barrier and you don't want to use plastic, you can use Icynene and it will act as a barrier and an insulation. So that's the quickest way to do a bay when you want to make it an air barrier, a stud bay. It's also the maximum insulation per inch. It shares that distinction with rigid isocyanurate, the stuff, the flour stuff. You've seen that. It's the yellow kind of powder. It's foam, but if you rub it, it kind of goes into yellow powder, that stuff. But if you wanted to use that in a wall, you'd have the problem of cutting it evenly. But what you could do is put a couple layers of that in the wall and then just Icynene the very last inch, and that would seal the air barrier. So that would work in combination. Okay. When in the BPI testing, which we kind of looked at in a hurry, they do combustion testing and they do leak testing. So there's a difference. Combustion is when something's lit and you're getting combustion gases. Leaks are just the raw in the gas before it's even burnt. So they do leak testing also. So when they go with a gas sniffer, that's a little machine that's got batteries and it makes a clicking sound. And when there's a lot of gas, it clicks higher, it starts going faster. But it doesn't pinpoint it. It just that ambient gas in the area makes it click more. Then you have to go down with a little soap, those little soap sponges, and you've got to go around that area and just coat the piping, and you'll see the bubbles where there's a gas leak. So it's kind of a two-part process. But where are the leaks going to occur when you've got gas? How is gas piping brought to, say, a range, a stove? Anybody put a stove in with a gas pipe recently? So gas comes in rigid pipe, steel pipe, to the area we're going to use it, and then you use a flex duct, right? I mean, a flex pipe. You seen those? Because you don't want to have to bend copper or steel around to find that where we're going to use it. You want to, if it's a stove, you want to just take the thing and connect the stove to this rigid outlet, gas outlet. So it's at those connections with the duct, with the flex duct and the rigid pipe that's going to probably be your leaks.
Do those gaskets wear out over time?
Yeah, the flex duct, they actually tell you if it used to be before 1976, but that was 73, that was a while back, so it's probably a later date. But they only have a certain lifespan. Oh, here we go, update. Okay, evacuation warning due to Aliso Fire area east of El Capitan Beach State Park, west of Dos Pueblos. Wow. That's coming closer. God damn it.
Yeah, Patrick, I drove through the fire. I think right before they closed it, the 101.
Yeah. Where was it then?
It was right at Gaviota, but it had already crossed over to the train track side.
Gaviota or what's the next one? Refugio.
No, it was at Gaviota. It was
Okay,
on
no,
the
it's down.
train
Dylan,
track.
did you hear that?
Yeah, I heard that.
So east of El Capitan, so it's lower than El Capitan. It's even closer to me because Dos Pueblos is between me and El Capitan. Oh man.
It's like somebody's gonna have work off tomorrow.
Yeah,
Yeah,
you never know. They can get contained enough to where I can go in. I'll keep communicating and checking tomorrow. Who knows?
I
might have to
I gotta
go
be
to-
ready to throw my computer in the car and anything I hate this.
I
Hopefully,
might
it
need to
doesn't-
go to Earl Warren's tomorrow.
What's that?
Might need to go to Earl Warren's tomorrow. The showgrounds. If they're taking the animals anywhere, they're taking them to the showgrounds.
Okay, so gas leaks occur by connections, okay? Not in the straightaway. So it's the connections you want to check. And then after the rapid clicks, what do you do?
soap sponges.
Soap sponge. Replace gas flex duct when older than 1973. They usually have a little paper tab on them that tells when they're installed. And if it's kinked, right? Or if it's corroded, yeah? Okay, CO stands for what? The chemical CO.
Carbon
monoxide.
Carbon monoxide. Mon means one. CO2, carbon dioxide, two oxygens. All the difference in the world between those two. We need one and the other will kill us. So, and CO is tested for at every combustion appliance vent. So every time you have a combustion appliance, hot water heater, range, where that gas starts to go up into the vent, you need to test it. Also, in garage or mechanical room combustion zone appliances should be tested for carbon monoxide leaks. Not leaks, but for carbon monoxide gas, natural gas leaks, and adequate draft. You know what draft is? That's the pressure that sucks the gas up through the pipe, the vent. And it's got to be a certain pressure because the house is pulling the other way on gas. So if it doesn't have enough draft, then it could backdraft, go the other way. What is a worst case depressurization test trying to determine? Anybody remember from last week?
Was that pressurization or depressurization?
Depressurization. So if a house gets too depressurized, that means it's sucking air from outside it, right? And before it sucks through the cracks, it'll suck through any chimneys because that's just a straight run to the outside if it's a natural draft chimney. So you have to, all your combustion appliances have vents and you can test the draft in the vent. And the depressurizations, testing that draft. And the test involves having all the fans go in the house at once. So you get extremely negative pressure, which is not unusual because it's very probable that you'll have many fans going. And then when you test each appliance, you got to make sure that all that depressurization is not pulling air down the vent instead of up the vent. And so if it pulls it down the vent, you could have a rollout, because a lot of times the heating element's right next to that, and it's getting air from the room. So if there's gas coming down, it could push that flame into the room where the air opening is. And if there's anything near it that can light, it can light on fire. So that's what backdrafting is. And then spillage is just vent air coming back. So if you take a mirror and you hold it up like in a hot water heater, there's a little gap between the heater and the vent. It's open to the air. And if you put your mirror in there, a little mirror, it'll fog up. It'll always do it when you start it up, but that thing's ongoing. So if it's ongoing or you give it 10 minutes, it shouldn't show that little fog, because that means it's spillage happening. It's spilling back. Name 3 areas of leakage in a house. I think we did that earlier. Name 2 things a blower door test will indicate. We're almost done, you guys. Hello?
Yeah, we're here.
Can you repeat the question?
Yes. Name 2 things a blower door test will indicate.
Lucas, I'm in class. You guys should fuck up.
Was that it? That wasn't an answer. I think that was it.
Was it like leakiness and how airtight it is?
That's one, leakiness. So we didn't do it in that demonstration because we didn't get it to work. But I told you I was going to go around with a piece of incense and see where the air was being sucked out of or sucked in. We did a depressurization. Same place, it goes in and out. You hold it near a window and you can actually see the smoke stick or a cigarette or a incense. You can actually see the flame being pushed in where you have leaks. So it's a great way to find leaks. So 2 ways: finding leaks and determining leak. Those are the answers. Okay, BPI audits consist mainly of air leakage and combustion safety tests. That's true. They do a blower door test and they test for leakage, and they also do the combustion safety, partly because that uses the same equipment. It uses that blower door pressure. The little computer can find pressure differences. So natural gas sniffer, what is that sniff for? Natural gas? Okay.
Is that a trick question?
No, I have a different answer than natural gas. I have some other gas. All sections, last question. All sections of vent or flue pipe should be tilting at least partly upward and not level from the source of combustion. Because hot air rises, so those gases have to always be going even a slight bit up. But I'll show you some pictures in a second where they're going down.
Is it like water, like 1/4 inch per foot, or is there a specific?
That's a good question. I think there might be a 1/4 inch per foot, something like that.
Right.
I think it's probably less, but I think they might do that because it's easy to remember.
Yeah.
Okay, so I'm going to switch to a few pictures from our handouts, and then I was going to show 2 videos, but I think I'll just maybe do I don't know, I'm kind of nervous about this fire, but I'll do the I've got a YouTube I want to show you, or
Patrick, is there just one answer for the natural gas sniffer thing, or are there multiple answers?
no, I asked you if it tests for CO.
Yeah, okay. Yeah, I just looked it up and the ones out there test for like 4 different things. Natural gas, methane, propane, carbon monoxide.
No, no, I said test for CO and you just put false. So you don't need to know the other things. Yeah?
But some of them do test for CO though.
No, not a natural gas sniffer. So you can either get a sniffer that's only for natural gas, or you can get a multi-sniffer and you turn it to the natural gas. If it says natural gas sniffer, it means it's turned to the natural gas, angle.
Huh, okay.
Okay, does everybody see this on the screen? Hazards in the home?
Yeah, we see it.
Yeah.
Okay, so we're gonna look at that later. I just wanted to show you some, oh, here's the recessed can we talked about. They have to be rated a certain way. Yeah, no, we don't want to stop here. Oh, wait. Replacing a gas line before 1973 uncoated flex line or any severely corroded. There's a picture for those of you who like pictures. This one is a laundry flex duct and it's too big of a bend here. I don't know what that one is. Oh, it's got, this one's good. It's going up. This one's good. It's going up. Flue actually slopes a little downhill. I can't tell. It looks like that's going uphill, but it's saying it's. Look at these. Wow. Gas leak detection. There's one of those little soap solution, child's bubbles, whatever the hell they call it. So first you use the thing around the joints. And when that starts clicking, then you do this to find out exactly where it is. Seeing that it'll look like that. Yeah. No, we don't need to know that. Nothing, know that. Okay. We're out of there. Okay, 4 minutes. We'll do this one. Can you all see this? Hello?
Oh,
Oh, we just see you.
Oh, you do? Oh, thanks for. Thanks for that. And we'll go right to. Okay, here we go. Now you see the duct blaster?
Yes.
System to conduct a total leakage duct pressurization test. The total leakage test measures all leaks in the duct system, both leaks in the ducts that are running outside of the house, as well as leaks in the ducts that are located inside the house. The basic concept of the total leakage test is really quite simple. we're going to connect the duct blaster fan up to the duct system, typically at a central return. We're then going to tape off all the remaining supply and return registers. We will then blow air into the duct system using the duct blaster fan and pressurize the duct system to a test pressure of 25 pascals, which is equivalent to 0.1 inches of water column. The airflow needed from the duct blaster fan to achieve our test pressure of 25 pascals is the measured total leakage rate. Before we begin to set up for the test, let's familiarize ourselves with the various components of the duct blaster system. First, we have the duct blaster fan. The fan provides the airflow needed to pressurize the duct system. Connected to the back end of the fan is 12 feet of 10-inch diameter flexible extension duct. This flex duct is used to direct the airflow from the fan into the duct system. On the front side of the fan, or the fan inlet, you will see a stainless steel flow sensor mounted on the end of the motor. This flow sensor is used to measure the airflow going through the duct blaster fan. Also included with the fan are 3 flow rings, which attach to the inlet and allow the fan to accurately measure a wide range of duct leakage rates. The duct blaster fan is adjusted by a variable speed fan control. The fan speed is adjusted using the knob on the face of the controller. Finally, the duct blaster system includes the DG700 digital pressure gauge. The DG700 gauge is used to simultaneously measure both the pressure in the duct system and the airflow going through the duct blaster fan. Both the DG700 gauge and the fan speed controller can be attached to a black mounting board, which has a clamp on the back that makes it easy to attach to many vertical or horizontal surfaces. Now let's get started setting up the duct blaster system for the test. The first thing we need to do is connect the duct blaster fan to the duct system. This is typically done at either a central return or the air handler cabinet using the blower compartment access panel. For this test, we're going to use the central return as the location to connect the duct blaster fan. Check the central return to see if there's a filter mounted on the filter grill on the back side, and if there is, remove it. In addition, if there are filters located at the air handler itself, these will also need to be removed before we can begin. To connect the flexible extension duct to the central return, remember to always clean off any fog residue from the duct blaster motor, housing, and flow sensor when you're done. Theatrical fog machines are available from many local theatrical supply, electronics, and hardware outlets. Thank you for watching this video demonstration of the Minneapolis duct blaster system. If you have any questions on how to use your duct blaster system or on other products sold by the Energy Conservatory, we'd be happy to hear from you. Thank you.
California homeowners, how would you like to get a brand new free air conditioning system when you upgrade to solar and erase your energy bills? That's right.
Okay. Ah.
Can you smell smoke at your house, Patrick?
I haven't gone out yet.
That just means you don't have any air leaks.
Yeah, I wish. Oh, fuck. Hold on. Okay, you see the screen now?
For today,
Yep.
Yeah.
Mike Horgan and Jennifer Rennick from Imbalance Greens Consulting. Further in detail.
Hi, this is kind of a broad spectrum of heat pumps for heating and cooling. We do like to tell everyone that Jennifer and I we've been doing these things in practice in the field. So this isn't just hey, we read about this. This is a good idea. A lot of these, everything that we're doing, that we're talking about here, are things that we're actually doing in the field. A lot of the photos will be from projects that we've either worked on or are currently building at the moment. So we'll go a little bit over who, what, where, why. This is kind of a broad spectrum of heat pumps for heating and cooling. We've kind of combined, we probably have 4 to 5 decades worth of info in this field, and we're going to condense it all into about 45 minutes. So we're going to do the best we can to give you guys as much information as we possibly can so you can carry it over to future conversations. We'll go over some of the how-tos, the how-not-tos, importantly, the how-not-tos, and we'll get into some of the science stuff behind it. We've broken this presentation down into 5 parts. We'll give a quick overview. We'll go over the various different types of heat pumps that are used for heating and cooling, and where they can be placed inside your projects, residential and commercial. We'll go over some of the considerations when installing these systems into your projects. We'll go over a few little nuances that are important to note that aren't always front and center when people talk about heat pumps. And lastly, at the end, we've got a few slides pertaining to costs and some of the talking points when considering these for your projects. So getting right into it. Heat pumps.
Lucas, don't smoke in the bathroom.
So we're talking about electric systems. So we don't have gas. We're not firing up a burner and using methane to create heat that we then push into a house through a bunch of various means. Heat pumps capture heat. They capture existing heat that's already in the air. There's heat in everything. There's heat even in the air down to minus 50 degrees that can still be captured by the refrigerants that we use today. So we have two units. We have an indoor and an outdoor unit. And there's a line set running between these two units. And in that line set, there's refrigerant. And that refrigerant captures the heat that's in the existing air, and it moves that refrigerant across a system that contains two fan coils, and pump pushes that air into our existing spaces. So we're not making heat, we're moving or capturing and transferring existing heat that's already in the air. So that's just scratching the surface of efficiency. We're using something that's already there to help us condition our spaces. There are a whole bunch of manufacturers pertaining to heating and cooling when it comes to heat pumps in the US. There are numerous installation companies across the Central Coast. There are a few up here in the SLO area who specialize in heat pumps, and they're actually talking to one of the owners the other day. They're seeing most of their work shift towards heat pump and shift away from gas systems. So there are full companies that you can hire to install these systems. Most of those companies will do all types of the installations, the various different distribution methods. There are also DIY kits that you can buy. I've seen a little uptick in people buying the DIY kits around SLO. People doing their own ADU projects, really trying to conserve funds. I've seen them buy the DIY kits, and then I've seen them run into a little bit of trouble because lines have to be cut, and there are special tools that have to be used once the lines are cut. So the DIY kits, as simple as they may seem, there are some nuances that are involved in those. We're not going to get into that today, but you can email us and ask us if you're thinking about doing DIY kit, but they are available, which kind of hints to how easy these things are. Like they're pretty basic systems. If they're selling them off the shelf at Home Depot as a DIY kit, it's got to be fairly simple for non-tradespeople to be installing them. So there are various sizes and different installation options. There are generally two main options. We have ductless systems, which is kind of what I prefer to install in projects if I have the opportunity. And there are also ducted systems, and there are kind of two kinds of ducted systems. One of them is almost like a hybrid, and it's a little nuanced. So largely there are two, ductless and ducted. Single zone, multi-zone, you can use numerous different types of indoor heads off of one or two outdoor heads, depending on the size that you need. So you could have a 3-story apartment building and have 3 indoor units running off of one outdoor unit outside. And you could have 4 wall-mounted units, we'll get into the different kinds, and then maybe 2 ceiling-mounted units also running off of the same outdoor system. 2 things to really take note of. You cannot have heating and cooling at the same time, but these systems do provide heating and cooling. I think, Jennifer, correct me if I'm wrong, but they're coming close to having systems that can provide heating and cooling at the same time. I think it's in the works, but not readily available yet.
Yeah, for the systems we're going to talk about today, these smaller scale systems, it's what Mike said. You can set your system to auto, and it will figure out for you. The brains on board will figure out by looking at the different thermostats you have, if it's going to be in heating mode or cooling mode. And then you can move to more complicated commercial systems with variable refrigerant flow and heat recovery that is much more robust for like a big apartment building or something like that, or big office building where where it will heat and cool at the same time, but that's because they have multiple, branch boxes and systems in place. But for these more simple, straightforward systems that you'd see in small offices and residential units, it's just going to operate in heating, the one unit that can do both.
Two parts. I generally call it a condenser outside and a fan on the inside. But our installers might call it something totally different. So you've got a line set, which is two lines containing refrigerant. So it's a closed loop system, one going up, one coming back, going up, coming back. And then you'd have a condensate line, because in air conditioning mode, they will take condensate out of the air. It's just water, so it just needs to be drained into a drain, or it can be drained outside. A project I'm building right now, I'm draining it into a little bed that will be built in front of the wall. It's not very much water, so you're not talking about you're not going to flood it.
This little ring.
Call it what you'd like. Most people in the field will know exactly what you're talking about if you're talking about the outdoor unit. And you'd have an indoor air handler, not unlike what we'd have with the gas FAU system. It's basically the same setup, but you're not using fossil fuels. You're not using.
So this is a fully ducted
heat
system.
That heat throughout the building. But that's a fully ducted system. So you've got these design considerations, because you've got to consider, where are we softening down ceilings? Are we creating chases in our homes? Or do we have a closet where we're going to run ducts from first floor to second floor? It creates the same set of installation considerations as a gas FAU system. So we talked about the two systems, the ductless and the ducted. This is an example. I think you can see my arrow. This is an example of a wall-mounted ducted mini split that I installed in a project that I built. This is on the coast of New England. This is on Cape Cod, so maybe a quarter mile from the ocean, if that, from the New England Ocean, so not our nice warm ocean here. And this is, I think this was a 1-ton wall-mounted mini split. This was a few years ago. And this is the only heating and cooling that we have in this entire house. And this was actually a 3-story new addition onto a 150-year-old cottage, and probably a total square footage of 2,500 square feet. And that's the only heating and cooling we use for the entire upper 2 floors. We did have another system downstairs, which I was reminded of when I saw a picture of last week. But it's fairly simple. That's it. That's all our heating and cooling for that entire main living area in this house. And then you have also a ceiling mounted ductless system. So that's a wall mount, that's a ceiling mount. This is what's called a between joist ceiling mount. So it's made to fit between 16 on center joists with trusses, TJIs, whatever you're using. It comes with clips, and you can attach it to 16 on center framing. They're fairly big. I feel like this picture doesn't do it justice. When I'm in the office, I actually have one I can hold up, and you can see I'm 6'1", and it's not a lot smaller than I am in terms of length. So they're fairly large. I think I've got a picture of one from a project that we did across the street. This is a ceiling mounted system that we installed in the house right next door to me, outside actually. So you get a little bit of a scale idea. You have to point it out that it's actually mounted high up on a ceiling.
Might typically be spec'd with these days, and then what this new sort of equipment offers in terms of downsizing and efficiency.
Sure. I don't want to go too off track, because we could talk about that for probably 20 minutes, but.
See this,
Finding those terms.
see this
and
woman here,
what a
Michelle
typical
Zimri?
house that
She was a
isn't built
student
to
of
higher
mine
performance
in
standards
my
might typically
green
be
classes.
spec'd with these days, and then what.
So these are just other
building. So
systems.
Of equipment that Mike's going to go into next. This is like a new
square foot conditioned floor area, single feet.
really small pre-made fiberglass pad, because these units are pretty lightweight. You can set that pad on stable ground, bolt it to the fiberglass pad, You can also mount it to the walls with specialized wall mount racks, and those wall mount racks are easily purchased and made for the purpose. And then if you live in snow country, or if the ground really isn't in a situation where you want it on the ground, you can pour a concrete pad and mount it to that, or you can put it on a snow rack. And again, those are specialized racks meant for kids. And yeah, I'll let him tell you, but
it's a real photo. Yeah. It's a real project, but we did need to, it was used for,
it's okay, huh?
A pamphlet for, had a lot of hands in this.
Point out, if you go with specialized dryers, like heat pump dryers that don't have outdoor dryer vents, it's not a problem. But especially in retrofit situations, your clients might already have a dryer that's vented and
getting longer and longer as design progresses on these. And I say that, and I don't want to scare people to think, oh, well, so they're new and they're developing. Heat pumps have been around for decades and decades now. They're utilized the world over. Australia, New Zealand, China, all places I've lived, it's kind of the only system that they have. They don't use gas the same way that we do here. And a lot of people kind of look at it funnily when they do hear that we use gas the way that we do here and don't utilize such a simple system. So they've been around forever, but everything changes. Every day is a school day.
No, that's perfect.
To the outside, which then leads down.
Rather have it just up in the ceiling. This is another installation that is pretty popular for some of our clients, where this is that ducted ductless unit, which can be set up to have the ducts like Mike showed in that one photo with the big silvery insulated roof rafters or the ceiling.
Yeah, we get the picture.
And this is a chance here to say that, you know, we've talked a little bit about the fan coils. We've got refrigerant moving in between two sets of fans, essentially. So you'd have a coil, a fan coil in here, and another fan coil in here.
Project from the kitchen side of maybe if you're is distilled water. So there's nothing in the same amount that your exhaust fan takes out. So no longer depends on a leaky envelope. But in some cases, this could introduce too much cold air to a space when you're really trying to conserve energy. So even better yet, as we'd introduce what's called heat recovery ventilation. And basically you install one unit or pairs of units that allow the incoming air to be warmed up as it's coming into the house. So you don't just dump cold air
into the house. They're not introducing fresh air. They're recirculating the air that's inside the home. You know, you've got this smaller spaces, say within a system. I don't have gas run to this project, so I've saved 11. So this is the one that Jennifer was showing, where you'd have registers that don't look unlike our normal gas FAU systems that we're familiar with. 1,500 square foot home with 3 zones, independent controls for each zone. Figure about 20 grand, probably a little higher today, given the way prices are rising on the daily. A fully ducted system for a 1,500 square foot house, figure 12 to 15 grand. Since we put this together, probably closer to 20, just the way everything's rising right now. So
to highlight was
wildfire season hits. That's a good time to use that.
Oh, I forgot to shut it off. Hold on. So, you know, there's a lot of details that we don't need to know, but those systems are really sharp. Everything's going with those kind of systems these days, heat pumps. We have, we'll look at another video in the future class about heat pump water heaters, hot water heaters. So the reason they're becoming popular, well, one is they're cheaper and you can put them in focus points. And if you have an open floor plan, then all you need is one and it will go everywhere. If you have several areas, you might need a couple of those, but they just mount through the walls, and some have that split and some don't even have that. They just have a single unit up high. And, but also they're electrical powered. So when we're getting away from gas operated systems, and there's no combustion involved. So we don't have to worry about fires being started. We don't have to worry about greenhouse gases unless the electricity is created by an oil plant in your neighborhood, but we're getting over that as fast as we can. So they're really kind of the wave of the future right now. And, you know, they're like refrigerators operate on that principle. And what else? Air conditioners operate on that principle. So we've had those for those two appliances forever. And somebody made the bright idea, well, let's start making heating and cooling units with that same technology. So it's flying now. So that'll give you an idea of what is out there. Any questions about that stuff? You can ask questions more about the technology and how it works when we do the hot water heater. We'll maybe have more time. I'm a little nervous about the fire, so I kind of speeded through that YouTube. But let me take real quick and then we'll go home, huh? And I'll try to save my house.
Patrick, can I talk to you for like 2 seconds after class?
Yes, absolutely.
Cool. Thank you.
So, Miguel, Jesus,
Here.
Alec,
Here.
Lewis,
Present.
Jack,
Present.
Adiar, Zach.
Here.
Oh, here. Wake up, Zach. Okay, Eric Mendez, you're here. Dylan's here. Joel Santos, I think I saw your.
Yeah.
Yeah. Hi, Joel. Michael Silva's here. Jose Silva.
Here.
Yeah. Thanks, Jose. And John Tapia. Okay.
Here.
Cool. So, yeah, Jack, I'll stay and talk to you, and everybody else can go. And remember, we're having the midterm next week. It'll be Monday night, same as class, only I will probably open it at 5 and let it go till 10. So you have 5 hours, 50 questions. We went over a lot of it tonight. If you missed the prep, it'll be on the recording, which I'll put on either tonight or tomorrow morning. So you'll have it during the week, you know, in your announcements section of your Canvas. So you can go over the first part if you came in late. And it'll be a Canvas test, you know, on that format. It's real easy to do. And I'll be on the Zoom in case you have a question, and you can go on the Zoom and ask me if you're having a problem with one of the questions or you need some help, just feel free. And if you can't get a hold of me any other way, call me, but I think you can just do it through the Zoom. Okay, any questions? Okay, well, be well, be safe, get out of the way of the fire if you can. That's what I'm gonna do. And I don't know if I'll see you next week, but we'll have the test next week, okay?
All right, thanks, Patrick. Hope all goes well.
Okay, you're welcome. See you guys.
Thanks, Patrick. Stay safe.
Yeah, thanks. So Jack, where are you? It's dark.
Yeah, I just went to run a quick errand. I had to drop something off before I got too late. But so I was thinking about joining the Navy, and I'm trying to do the CBs. It's like the building battalion, the construction battalion.
Yeah.
And I've like been setting up on the ASVAB test and stuff, and I'm gonna talk to a recruiter tomorrow. And I was thinking if I was to like draft up some sort of letter like saying that like I'm attending, because I haven't finished classes yet, but I just want to like prove that I'm in classes for construction.
Yes.
So I was just wondering if I like write a letter of not recommendation, but just saying that I like construction classes and stuff. Would you like sign that for me or something?
Oh, absolutely.
And I can give you your phone number.
Yeah, of course.
Cool, because I know it's pretty competitive to get into that, and
Yeah.
that's the program I want to do.
Yeah. Well, my phone number's on the,
Are you? I have your phone number.
It's
Is it? Hold on. Are you 3187?
yes, 455-2187.
So I'll text you if anything. Then thank you very much.
Okay, you're welcome, Jack. No
Okay,
problem.
bye. Thank you.
All right, bye-bye. Eric, did you want to talk to me? Eric?